Alright, so we're now going to talk about some ways to describe a data center. In other words, some ways to describe where the bulk of data are, or where the middle data values are. One way to describe a data center is with the mean. So the word mean just means average. So when you hear mean from now on in your mind, you can think average. So the mean is the number given by adding up all the data values and dividing by the number of data values. So for instance, let's say we wanted to find the mean height of all men in the world. So in order to do that, you would have to grab every man in the world, record his height, add up all the heights, and divide by the number of men. That would give you what's called the population mean, which we represent by the Greek letter mu. So if you see mu from now on, it will stand for population mean. And now, so this formula here is a formula for finding an average. So this funny looking E thing here is the Greek letter sigma, and it means take the sum. This letter N here, capital N, represents the number of data values in the population. And these X represents your individual data values. So what this formula is saying is to find the mean height of all men, or the average height of all men, which would be our population mean, you would need to take the sum of all of the heights of all men, of all data values. You have to add them all up. You'd have to divide that by the number of data values. So you'd have to, there are probably 3 or 4 billion men in the world, so you'd have to add up all 3 or 4 billion men's heights, and then divide by the total number of men in the world, which would be 3 or 4 billion. Now, realistically, I mean, that's going to be impossible. So instead, what we would do is we would try to estimate the population mean height of all men. And the way we might estimate the population mean height of all men is by taking a sample. So for instance, you could grab a simple random sample of, say, maybe 40 men. And maybe you found that the average height of those 40 men was 69 inches. Then you would say, okay, my sample mean is 69 inches. So I'm going to estimate, well, since I grabbed 40 men and I found out that they had an average height of 69 inches, I'm going to use that and say, I'm going to use that to estimate the actual average height of all men. And say, well, I grabbed 40 men, the average height was 69 inches, so I'm going to guess that the average height of all men in the world is 69 inches. So in that case, we took a sample mean. That's what this stands for, X bar, sample mean. And so to find your sample mean, you have to add up all your data values. So in this case, if we grabbed 40 men, we'd have to add up the 40 men's heights. And then we would have to divide by N, which stands for the total number of data points in our sample. So in this case, our little n would be 40. All right. So in general, we use our sample means to approximate population means. We use X bars to approximate mu's. All right, so an example. All right, let's calculate the mean of the following data here. So maybe this is 5 data points. All right, so we took a sample of something, we got a collection of 5 numbers, and we want to find, well, what's the average? Well, in order to do that, we got our formula. X bar equals the sum of the x's divided by n. So in this case, here are our x's. 15, 20, 40, 50, and 120. So we got to take all those guys and we got to divide up by the number of data points, which is 1, 2, 3, 4, 5. And if you do that, you get the number 49. All right. Now, so what are some advantages to describing a data center with the mean? Well, one advantage is this. Different samples generally produce the same mean. So if you're trying to estimate the average height of all men and you grab 40 men, well, you'll get a sample mean. If you grab another 40 men's heights and find the average of those heights, you should get a number that's about the same. So sure, you might get some tall people and you might get some unusually short people, but those are going to balance each other out. So if you grab 40 men over and over again, you would expect to usually get about the same number. So different samples generally produce the same mean. Another advantage of describing a data center with a mean is that all data are used in its calculation. So in other words, no data point is ignored. You're not ignoring any data. So if you're trying to describe where the bulk of data lie or where typical data values lie, and you give the mean, well, you haven't ignored anything. But this kind of becomes a disadvantage to describing a center's data with the mean. So you do have this problem that outliers can greatly affect the mean value, especially in small samples. So we saw this in the Chapter 2 homework. If you're trying to estimate the average salary of women in Corpus Christi, and you grab 20 women, and most of those 20 women make around $50,000 a year. Well, if one of the women made $5 billion a year, the average salary of women would be millions upon millions of dollars. So one unusual data point or one outlier can greatly affect the mean. So that is one disadvantage of using the mean. It is affected by outliers. And so if you're trying to describe to somebody what the typical woman makes in Corpus Christi is, well, if you use the mean and you found your mean by, taking 20 women each making around $50,000 and then a woman making, a few $1 billion, that will greatly distort the number you are reporting to that somebody. And it makes it seem like women are making more than they really are. Okay. So that is avoided by describing a data center with the median. So the median is the middle data value found by arranging the data in increasing order. It's the halfway point of the data, since half the data lie above this number and half lie below the median.